Team 2, we're going to follow this process. We're going to read the given carefully and mark it on the diagram. We're going to mark what's implied by the given. We're going to mark any freebies. And then we're going to talk through how we know to hit the prove. Let's start by taking a look at our given information. We are given that EF and ED are congruent, so let's trace those. That's EF and ED, the segments, are congruent. And then we're also given the fact that EH and EG are congruent. So EH and EG are congruent. That's our only given information. So we're done with the given. There's nothing really directly implied. We'll look at what we're trying to prove here. We're trying to somehow connect angle F, which is way out here, to angle D, which is right here. We're trying to somehow show these two are congruent. Now, if you notice closely, there's some overlapping triangles, and whenever you see overlapping triangles, you want to make it a habit of pulling those overlapping triangles apart. So you have one overlapping triangle, that is EFG. We're going to pull that apart right here. And then we have this other triangle, which is EDH. Pull those apart very carefully. Now remember, we're trying to connect D and F. D and F are the corresponding angles. Well, if there's a way we can get these triangles are equal, then we can say the parts are equal by CPCTC. So our goal basically is going to be this. How can we get those triangles to equal to begin with? So let's mark implied. There's nothing else implied, but be very careful. There is a freebie here. These two triangles, the orange and the pink, let me go over those again. Take a look. The orange and the pink, they overlap at exactly the same angle. I want you to take a moment as Team 2 and try to find which angle do they exactly overlap and sweep it, please. Which angle do they exactly overlap and sweep it? Okay, you should have swept angle E because you look closely, both triangles exactly overlap at E. So we're going to come over here, we're going to mark our E as congruent. And we're going to say A for an angle. Now let's look at our given information. Our given information was EF and ED congruent, so we're going to come over here, hatch, and ED congruent, hatch, that's an S, and then we're given EH and EG congruent, so EG and EH, double hatch, and side. Now let's talk it through with between our given, our applied, and our freebie information. We can see the triangles are going to be congruent by side angle side. And if the triangles are equal, the parts are equal, which would be that angle F and D that we're trying to do. Now for this time we're going to do a two-column proof. So step 1, we're going to put on the left, I know that because of, and so we're going to follow these steps. Our goal is to do side angle side here. That's step 1, step 2, step 3. So step 1, we're going to go for our first pair of sides, which was the blue ones, which is EF congruent to ED. And that'll give us a pair of sides. And the reason we know that is because it's in the given information. Okay, number 2. We have those congruent angles, and so that's going to be angle E is congruent to angle E. That gives us our angle. And the reason why we have that angle, it's reflexive angle. So there's our congruent sides, our congruent angles. Number 3, I know that the other pair of sides, EH, is congruent to EG. And the reason I know that is because it's in the given. Now we have sufficient information. We have a pair of sides, a pair of angles, and another pair of sides. That allows us to say that the triangles are equal. So we have triangle, the pink triangle. We're going to start at E. We're going to go E, F, G. The pink triangle is congruent to E, D, H. That was the orange triangle. And the reason why they're congruent is because of the shortcut side angle side. Now finally, if we say the triangles are equal, we can say the parts are equal. So now we can hit what we're trying to prove. We can finally say because the triangles are equal that angle F is congruent to angle D, and the reason why is because if the whole triangle's congruent, parts congruent. Fancy name for that is CPC-TC.